a little over a month since we've done this. So I appreciate you
Mhm.
guys' patience for the two or three of you guys that are interested in this podcast. We are back. May was kind of crazy for both you and I, and then you had
Yeah.
some work assignments. And but we're here. Remind humans who you are, Richard.
Richard Fletcher. Nickname, I guess, engineer of reality. That's what Facebook wants to call me. So I started a YouTube channel after that. But um, I'm an engineer in telecommunications and
What
radio
do you
frequency.
mean? That's what Facebook wanted to call you.
Yeah, I mean that's what they started. Well, I started to get a little moniker from that, from followers and stuff like that.
Oh, got it. The humans on Facebook is that's what they kind of coined you.
Yep.
I don't think I should say what people call me. Uh, if I called my YouTube channel or my Facebook what people call me, uh, they'd get banned really quick. My name is Edgar Antillon. I am nobody. I am nothing. I just like science. I like to talk about science. It's it's one of those things that interests me. It's a fascinating field. I've always been one of these humans who, although I absolutely hate school and hate the idea of going to school and being in a room for 8 hours and all that stuff, I thoroughly enjoy learning on my own. Um, and a while back, I seen some of your posts. I was like, well, maybe we should talk about this on the internet. And here we are talking about it on the internet. But like I mentioned, life gets in the way. So we've been off for about a month ish, if not a little bit longer than that. That speaks to how difficult it is to do this. So hopefully we get one day to a point where um although it's difficult to do this because life gets in the way, where the resources kind of allow us to do this a little bit more consistently. Um, but yeah, I don't even remember where what our last episode was, so I don't even have corrections or um. Usually, what I like to do in the episode is correct any bad information, any information that either disinformation or misinformation. There's a slight difference. We like to correct that information, but it's been so long since we've been at it that
Mhm.
I don't even know what we were talking about. So I think I'm just going to leave it alone and understand that if we did share some bad information, understand that Richard and I are humans who are not necessarily we're not physicists, we're not professional engineers, so we're just learning stuff.
Hey,
That's
wait.
really the biggest thing about this is we're just here to learn. We're just here to kind of help each other out and really again learn from you guys more than anything else. I don't even know if we're trying to educate anybody. We're just trying to talk about topics about stuff. Uh,
Yeah. Uh, First correction is I am a professional engineer. This is what I do. Wait a minute.
wait a minute. Uh, Cullum's law was the last
Comes law.
okay. Um, well, if we do need to do any corrections, we'll do it from there. Yeah, you are a engineer. That's your education. I I always forget that electrical engineers are technically real engineers. Uh, my
Yeah.
cousin, he's an electrical engineer. My uncle, he's an electrical engineer, and I've had this conversation with him. Like it's just it's uh,
Imagine things you can't see.
correct. Yeah, yeah. So, what are we going to talk about today? Speaking of electricity and electrical engineering, uh,
Yep.
what's the topic for today? You have one, and then I have
Mhm.
one. This is probably not going to be a super long episode, um, but at any rate, go for it.
So we're talking about quantum electrodynamics. Basically, how one charge knows that the other one exists. That's pretty much how it works. So we were talking about how charges can kind of push and pull against each other. I think we discussed that about why you can't walk through walls and things like that. So now we're basically talking about how they recognize each other, or how it knows the spin of one electron versus another.
But so this is all electrons. My understanding of this, which is very little, and that's why we're here, is that it's how light and matter interact. Is that the that like the concept? Is that the basic principle? That's the problem
Mhm.
with science, right? Is you always say the very general thing that's easy to talk about, understanding that it's much more nuanced than that. But I understand it as the way light and matter interact.
Yeah, so basically, charged particles interact by constantly tossing tiny packets of energy back and forth. So, um, photon packets, pretty much. That's what they're tossing back and forth, and that's how they're able to identify or interact with each other. So it is light and matter.
So, yeah, you're gonna have to say that differently because my brain, no fucking clue what the fuck you said. So, I've got this blue light right here that's fucking coming out from the light bulb that's right above me, and it's
Hmm.
and then it hits the matter, my head, and at a quantum level, there's a communication, where they talk to each other so that they know how they're going to interact with each other, or am I wrong about that?
So the only thing that you may be wrong about is it's not visible light. It's virtual photons. So you're not able to observe the actual light.
Got it. Because this is all quantum.
Yeah,
This is all super duper small stuff.
yeah.
So, here's what, AI says, and again, take it for what it's worth, it's just AI. I'm using Google AI, and they have all they do is just pull up the most popular, um, write-ups about this. So please be mindful, because sometimes it's Reddit, and then sometimes the Reddit post just becomes super interesting. Unlike this, we had like 30 people, and they're like, "Fucking science, we're gonna get off of this." Uh, Fuck science.
Did that just happen?
Yeah, 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 for sure. That did just happen. I have that effect on humans. Super duper have that effect on humans. But here's what it says. So again, it's AI. Take it for what it's worth. Quantum electrodynamics is the relativistic quantum field theory that describes how light and matter interact. It is the quantum counterpart of classical electromagnetism, mathematically unifying quantum mechanics with Albert Einstein's special relativity. QED is celebrated as one of the most rigorously tested and accurate theories in the history of science. That's according to Wikipedia. The core principles: force carriers, instead of continuous classical electromagnetic field, forces are transmitted through the exchange of fundamental particles called photons. Virtual particles, this is what you were talking about. Virtual particles, the photons exchanged between charged particles like electrons and positrons, are virtual. They exist temporarily as intermediaries to carry momentum and energy, mediating the interaction. Interactions. The theory details fundamental processes such as the absorption and emission of photons, electropositrons, annihilation, and pair production. I'll be honest with you, I have no fucking clue what any of that meant. Um, s
So in simple terms, it doesn't work like gravity. Like it's not a force that's actually pulling you. It's more like being hit by a bunch of microscopic dodgeballs. So that's It's using momentum of, say, a small ball or something to actually move you instead of gravity pulling you.
So is there a force involved with this then? I mean, it's energy, so there.
Yeah, it's not necessarily a force. It's an exchange of energy. So you have a certain momentum. So say you have say you're moving in one direction, and then you have an opposing force that's hitting you in the opposite direction, and then it causes you to move back in the other direction. That's what it's explaining.
That's fucking again, I say this a lot, that's kinda like the theme around here is science being explained and then me just saying how batshit crazy all of this is. And this is pretty well tested then, right?
Yeah, yeah, it's been tested and it's still being tested. So it's more information that we find out. It's kind of changing how we view reality or how we view physics.
I'm trying to find a picture that kind of, says it a little bit better. Not that you didn't say it better, but for my brain anyways, I'm gonna try and share it with you guys for those of you guys that are interested or are as dumb as I am and you want to, um, see this. I don't know that it's gonna do much, but quantum electrodynamics,
Oh,
Lagrangian.
yes.
And if you guys don't know who Lagrange is, highly encourage you guys to do it. The biggest thing about Lagrange, and if they're even talking about the same Lagrangian shit, is we've got points in space where things are kind of balanced out. That's where we keep satellites because of the way the it's two bodies, two systems, whether it be the sun, the moon, and Earth, or different planets. There's a point in which it's balanced. the the gravity of both of them at that point is mostly balanced, and that's, I don't know if that's what they're talking about here when it talks about quantum electromagnetic dynamics Lagrangian, which may be something different than what you're even talking about. But one, an electron, and it's got images, an electron goes from one place and time to another place in time. Two, a photon goes from one place in time to another place in time. And then three, an electron emits and absorbs a photon at a certain place in time. So you have an electron and then a photon that are moving, they collide with one another, and then the electron emits or absorbs a photon at a certain place or time, and then kind of thus changing the trajectory of that photon.
Yeah.
But this
So
is all done in shit we can't see.
right, and very rapidly. So think of an electron as like well, it's like the field ripple. And the photon is more like an electromagnetic field ripple. So it's kind the QED is kind of the rule book how those ripples interact.
Light with matter,
Yeah.
but
So
light in such a small and matter in such a small scale that we can't see it.
right.
But it's still just, I mean,
So light
we're kind
light
of
will be
seeing that.
photons interacting with matter. That's what makes light. So the photons interacting with the matter, basically like a light bulb shining on a surface. That's what makes light. So those are photons interacting with matter, and then electricity would be electrons and photons interacting. Then you have chemistry, which is electron behavior governed by QED, electro.
So how does this affect us? Like why is this important for humans?
Well, I mean, you got your phone screen is a good example of your of QED of chemical electron behavior that's governed by QED. So your standard LCD phone screens are kind of like a pressed chemical. Um, that when excited by particle fields or by electrons and photons, you see the light coming from your phone. So
But is that quantum though? Because now we're seeing it.
yeah, you're going to be able to see it. You're not seeing the individual excitations, but you're able to see, the end result.
So I asked the Google machine, um, and it says the effect on us. It says your body
Mm.
and senses. Vision exists because of QED. The theory describes exactly how photons of light interact with the retinal molecules in your eyes. Furthermore, nearly all which is kind of what you were talking about, a little bit what you were talking about. Nearly all biological processes rely on electrons transferring between molecules, which QED helps explain. Solid matter. The reason your fingers don't phase through a key, which we talked about this before, is
Yeah.
yeah, yeah, yeah. We've talked about how um, magnetic
Repulsion.
repulsion is what we feel, not necessarily the actual stuff. But the reason your fingers don't phase through the keyboard when typing is rooted in QED. The electrons surrounding the atoms in your fingers and the atoms in the keys repel each other through through the electromagnetic force. Modern electronics, your computer, which is what you were talking about, um, modern electronics, the computer or similar, or smartphones, I'm sorry, you are using operate on semiconductors. The tiny transistors in these chips require calculations rooted in quantum mechanics and electrodynamics to function properly without short circuiting. Lasers and medical scans. The Department of Energy notes that QED principles from the basis or form the basis for technologies like lasers and medical imaging tools such as MRIs and X ray scanners used to diagnose and treat diseases. So that shit's all over the place.
Yeah, yeah.
It's everywhere.
Um, One person you can look up is a theoretical physicist named Richard Feynman. I
Yeah,
like that he has my initials and my name.
yeah. Richard Feynman is he's he's dope. Yeah, if you guys
Mhm.
don't know who Richard is, I mean he's one of the most talked about physicists of the 1900s. The 1900s. Richard Phillips Feynman was an American theoretical physicist and Nobel laureate, laureate who made significant contributions to quantum mechanics and particle physics. Known for his offbeat personality, Feynman also is a gifted lecturer and author. Scientific contributions: Feynman's work on the Manhattan Project during World War II was crucial to the development of the atomic bomb. He later expressed regrets over use. Anyways, um, yeah, Feynman has is always is one of those humans that comes up in quantum physics
Mhm.
quite a bit. Um, I'll be honest, this is still one of those quantum physics in general for me is still one of those because it's already crazy. The universe, anytime you really talk about the universe, it's already crazy. It's
Yeah,
already bonkers.
yeah.
Uh,
Even he admitted it that nobody really intuitively understands quantum physics. We just calculate it insanely well.
I struggle to believe that even physicists really understand intuitively how quantum physics works, especially the electrical stuff, the stuff that we're talking about right now,
Mhm.
electromagnetic repulsion, because it's such a. I mean, you talk about superposition because this has a little bit to do with superposition. I mean, it's going to be affected by it,
Yeah.
and all of it is just like I don't. It's very difficult to wrap your head around this stuff. Uh,
Well, in a particle's movement, it's not going to take just one path. It's going to take every possible path, and then I would say that reality is basically the average of those paths. So what you're seeing is the average of every possible path.
Which every fiber in my being wants to say you're full of shit. Um, because that's it's batshit crazy. Like it's crazy that you say reality, but we've talked about this in previous episodes. I think 2 episodes ago or whenever we talked about it. This idea of how your brain
Mm.
is kind of correcting in real time for the reality. So like it's there is although I still want to say that's bullshit. That's sci-fi. There's still we have to accept, and maybe there the way it gets explained is very
Did,
sci-fi.
did you see the article I put out there about it? Man, everybody was in an uproar about that.
No, I didn't see it. Can you?
Yeah, where I basically said, you know, how your brain is canceling realities that you can't survive. Pretty much, that's what I was putting out. And
Explain that. I know that's not what we're talking about, but fuck it, we're here. Explain it.
yeah, basically what I'm saying is that your brain works on a buffer, and you're able to see that the reality that you see is the corrected version that your brain has already decided that you're able to survive. It's not. Um, you're basically only able to see about 10% of the actual reality. So,
Yeah,
uh,
there's a lot of works in psychology about this.
mhm,
This is where the gaslighters come up. And so there is already a reality about that in the psychology world. What we don't understand is how, and we should like if you think about this logically, everything in this universe is just energy. Everything in this universe is essentially the same. It's so cheesy and it's so cliche, but it's 100% true. So it makes sense if you understand how science works that
mhm,
your traumas, your psychological traumas, affect the way you survive and affect the way you build relationships and affect the way you communicate with other humans and you interact with other humans. But at the same level, there we still have to accept there's still molecules and there's still photons going into your body, and there's still electrons, and there's still positrons, and there's still neutron. Like you name it, everything you talk about in space is still interacting with your body and your brain, and your
mhm,
brain has to figure out how do I survive because that's what we're made of. uh,
yeah,
our our structure is slightly different than say um, just your plain old photon and molecule. It's a very complex system, but we're still just made of the same shit that's available in space. Like
right,
the ingredients that in my body are still just what's available in space. It's not more. It's not less. It's that's how we became the thing that we are. So I think that's the problem on one side you'll have people say, well, yeah, there are humans who make up their own reality to suit their life or whatever. And at the same time, you're like, well, no, that's just how quantum physics works.
right,
So from a psychological perspective, it's intuitive. Yeah, people do that, and sometimes people don't do it maliciously.
mhm,
You look at politics, and this is not a political platform, but you look at politics, they take the same information, and both sides come up with wildly different um, thought processes and solutions, and they both look at life very differently, but they're looking at the same information. It's just one alters the reality, to your point, to
mhm,
fit the narrative. We look at that as psychological because that's the easiest way we can explain it.
right, yeah. um, so basically, you know, reality wouldn't be considered a straight line. It's more like a negotiation. Your brain is negotiating as to what it wants to decide as a survivable reality for you as an individual person.
And but also based off of previous knowledge.
Previous knowledge, biases, trauma, everything is what's considered.
Yeah, but you're looking at this from a quantum mechanics, quantum physics. You're looking at this at a quantum level. Like how deeper can we go than just psychological stuff?
Um, I don't know how much deeper can we go.
Well,
Um,
I'm saying that's what how you're looking at it. You're not looking at
yeah,
it from a psychological perspective. You're looking at this from a almost physics perspective.
yeah. I mean, more from a physics perspective. If you want to bring it back to, the reality that you can see. Um, some analogies of how QED works would be like noise canceling headphones, where they're canceling out certain waves or adding certain waves in order to cancel out other waves. So you're looking at how it'll push out a certain frequency in order to cancel out a certain frequency. So it's interacting with that
Yeah.
frequency. Um,
So you're saying that your brain, in order for you to survive, may be doing something similar, canceling out certain noise, certain light,
yeah,
certain waves. I mean, they're both waves,
yeah,
manifested slightly differently, um,
hmm
but it's all just waves at the end of the day.
yeah. Multiple versions of paths that are just kind of it'll take interfering paths and kind of either push out a signal or cancel out interfering paths or basically votes on what version of reality you get to see.
Yeah, that one's weird. That one's a weird one. Um, and again, it's just not intuitive.
No, no, that's why it's still being studied every day and changes every day.
Um, well, I can't contribute more to that one. I need to study that more. I need to wrap my head around it a little bit more. I need to just plain old simple understand that a little bit more. So I don't know if you wanted to add a little bit more to that, um, or if you
Um,
wanted
I'm,
to go.
I'm excited to hear what you were bringing to
Yeah,
that.
mine's not that exciting. Mine's very intuitive, and
Uh,
mine is very low level. Um, so the stuff that I want to talk about it's one of these recent things that came up, and um, we we experience it on a day to day. But have you ever been at a pool and then outside? Well, let me ask you this: what
mhm.
temperature do you get cold at? I'll ask it that way.
uh, Standard air temperature probably around 60.
60.
I'm I'm pretty tropical. Yeah,
Yeah. Well, 60 is actually pretty cool.
yeah.
If you were to go to Florida and it was 60, people would probably start saying it's getting chilly. Um, but if you were to get into a 60-degree pool,
hmm That's pretty warm.
for the water,
Oh well, no, that's
no,
that.
if you get into a 60-degree pool, so that's what I wanted to talk about is if I'm not mistaken, and we could look at this, we could look it up right now. Um, but if you look at what temperature you can get hyperthermia in a pool, in water, in the ocean, um, versus out in the air. Like those temperatures are drastically different. Let me see. Water. I should have done this before. At what temperatures can water give you hypothermia? And obviously, this is going to vary. Water can cause hypothermia in any temperature below 70 degrees.
Oh man.
So if you think about this right now, in where I'm at, I don't know what the temperature is. It's pretty warm. But at 79 degrees, um, to your point, you can be outside at 60 degrees and be
Mhm.
comfortable or start getting a little cool. But you wouldn't be freezing. You wouldn't die. You wouldn't catch hyperthermia. You've probably been outside in 60-degree weather, taking a hike, walking the dogs. Uh,
Mm.
it's not something people really think about. I, in 60-degree weather, am fine. I'm almost perfect at 60-degree weather. I would argue that it could probably even go a little bit lower than that, in the high 50s, mid 50s. But once you jump into water that's 60 degrees, you start to get into the dangers of our hypothermia. Obviously, how long that would take versus if the water was colder, we could argue that. But this is a fascinating thing about thermodynamics.
Yeah.
So the way my body interacts with whatever's around it. Um, if you go into space, you won't freeze, even though it's well below. What's the temperature of space? Do you know it?
Um, 0 degrees Celsius, I would believe.
Is
That's
it?
no, I think it's colder than that, but
Temperature of space. It's negative 55. Temperature in space isn't a single
um,
number. Yep, I get it. The baseline temperature is negative 455. Um,
negative 455.
Negative 455. And if you do it in, let's see, low Earth orbit, in the temperature of space in LEO is, and it gets measured in kelvins. So we have to understand that it does get measured in Kelvin. It's
Yeah,
negative
light temperature.
65 in the Earth's shadow, to negative 100. So negative 85, negative 148. I'm sorry, in Fahrenheit. I was reading that differently. But we
Mm,
always have this image that if you go into space, movies tell us this, TV shows tell us this. If we go into space and we don't have a spacesuit, where we're going to freeze or somehow we're going to blow up or whatever. But very common that you freeze. And the reality is, it would take significantly longer in space for me to freeze at negative 85 Fahrenheit, say we're near the Earth,
mhm.
than it would be for me to catch hypothermia in a 60-degree pool. Um, it's just weird how these molecules, which we were talking about, in water, they suck out the heat. That's really what they're doing more than anything else. And I'm being general about this, but the water's so closely packed to you, so close to your body, and in high concentrations, that it's sucking essentially the heat out of your body.
Mhm.
You get into air, our atmosphere, and they're not as close to your body. Air, to a certain degree, is a relatively bad
Conductor of heat.
conductor. Yeah, yeah, it's pretty bad of conductor of heat or all that. That's why it makes okay insulator. A lot of insulation is just layers of air. If you ever
Mhm.
see old school stuff, it's some of it is just layers of air. Just really bad at that stuff. That's why I'm in 60-degree weather outside. Me walking the dogs, not going to have a big deal. 60-degree water, depending on many conditions, but overall, in general, I can catch hypothermia. In space, you're in a near vacuum, so
Mm,
everything's so spread out. Everything isn't compact. There's no atmosphere applying pressure to those molecules. Here on Earth, we have our atmosphere, but in
mhm.
space, at negative 85, negative 100, it would take several hours. It's going to happen. It's still going to happen because you still are losing. But again, it's again, this is just a general conversation. I would get hyperthermia in the Pacific Ocean before I freeze in space,
Okay.
which is wild to think about
Yeah.
because it's still
Yeah,
temperature.
'cause I'm yeah, I'm still my mind is like trying to pull the vision of freezing in space. So, like,
How
can you actually freeze, or would it be more of a petrification? Because how much water is in space for you to actually freeze?
well, it'd be your water.
It'd be your yeah. Okay.
Yeah, it'd be your water, so it would still freeze because you still have moisture in your
Uh,
system. So I think that's the argument is your own moisture is what's freezing. I get what you're
mhm.
saying though, like in space, you're in a near perfect vacuum. There's really no moisture because it's all sucked away until it attaches onto an asteroid or something like that. But let's see,
Yeah.
how long to freeze in space? Again, these are all just general stuff because it depends. In the vacuum of space, your body will not freeze instantly because there's no air or matter to conduct heat away from you. Your body heat can only escape via radiation, which is a slow process. It would take roughly 12 to 24 hours to freeze completely solid,
Mm.
um, which is crazy. You'd be long dead from the other stuff. No oxygen,
Yeah.
no atmosphere. Like you'd be long gone way before that. Gases inside your system. So
Die from bloating.
I don't know if you would die from bloating because again, it's a vacuum. So I don't know.
Yeah.
It,
Would it
would it be a
would things
bloat
be
or would
pulled
it be a
apart?
compression? Right? Because when you put stuff in a vacuum, it usually compresses it. It doesn't expand it.
Does expand it? Yeah.
Um, unless I'm wrong on that. But anyways, just fascinating. This whole idea of how we measure temperature and how it affects us, and temperature is not what we think it is, and heat and temperature are not the same thing. Even in space, there's no temperature. They measure it in kelvins, not really in temperature the way we measure it down here in on Earth because of
Which
the
is
way the molecules interact. What's that?
Kelvin would be measured in light, pretty much.
No, they still measure heat in kelvins.
Yeah.
So up in space, it's still it still gets measured in kelvins. Temperature in space isn't a single number. In deep empty space, the baseline temperature is negative 455 or 2.7 Kelvin. So they measure it in Kelvin um, for heat
Okay.
or coolness, heat or coolness. Yeah, it's weird. It's pretty fucking weird. We know Kelvin for lights here on Earth. Yeah, because light
Like yeah, color temperature.
color temperature. No, it's also a heat, the way we would think about heat temperature as well. Yeah, for sure.
Interesting.
That's a weird thing. So not as batshit crazy as your quantum electrodynamics, but it's still one of these fascinating things on how our body interacts with different layers. Even here, different layers of our atmosphere.
Mhm.
The higher you go up into a mountain, um, the less atmosphere we have. So the colder you feel, it affects you. When it's this happens in our house all the time during summer. 70 degrees feels miserable, but during winter, 70 degrees almost
Feels
feels
amazing.
cold. So
Yeah.
it's this weird. In my house, 70 degrees feels cool,
Mhm.
but I walk outside in 70 degrees and I feel like I'm burning up just because of the way my the molecules are interacting with my body. It's a fascinating thing.
Yeah, yeah. It's like right now in my house, it's set. I think my thermostat's set to like 78, but my AC is blasting right now, and I'm freezing. So
At 78?
it's set at 78. I'm not sure if that's what it actually is, but
Holy shit, that's hot.
yeah,
Se
AC is blasting. I feel like an ice cube in here right now.
But your AC is set to 78 degrees?
That's what the thermostat says.
What?
Mhm,
Holy
mhm.
shit. That is hot as fuck.
I told you I'm tropical.
Yeah, I don't know how you're tropical, 'cause
Yeah,
you're from the East Coast,
from the East Coast, but,
not even down
born
south.
born half Nigerian, so, I mean, hey.
Yeah, your parents were Nigerian. You were born in the East Coast in cold temperature.
Yeah, in the water, the salt water.
Still cold, 'cause you were, like, n north a little bit.
Mhm.
Yeah, you're
Yeah,
north more,
yeah.
'cause you're still north of Washington, DC.
A little bit. No, I think I'm just east of DC. I was, born, like, right outside of DC.
Yeah, that's cool. That's not tropical.
I travel.
That's not tropical.
I've been claiming it all my life. It's okay.
Yeah. Um, I don't know if that gets caught up in your DNA, but both my parents are Mexican, and I
Yeah.
was born here in the US, and you would think that I would like the heat, and I can't. My body cannot do heat. I am an Arctic Mexican. Um, my body does not do well in the heat at all.
Mhm.
Anyways, I think we've exhausted both conversations. Two fascinating topics about science, quantum, electrodynamics, and whatever you call the other stuff, just basic thermodynamics. Um,
All
anyways,
fun
anything, go for
stuff.
it.
So it's all fun stuff, and we still can't walk through walls. We're gonna figure this out
Still
one day.
can't walk through walls. We still
Yeah.
cannot walk through walls.
Mm.
And by the way, I think we found out that even ghosts would not be able to walk through walls, which
Oh,
proves
yeah.
again that there no such thing as ghost,
Mhm.
um, because they can't do that. Cannot do that.
They can't walk through walls. They're
And no, because they would be energy, and
Mhm. They would
according to
repel them.
science, there'd be electromagnetic repulsion, unless they were something different, like neutrinos, in which case they wouldn't be ghost because that's not what they would be made of.
Mhm.
So ghost ain't real.
No.
Be real.
I
Anyways,
just I think ghosts are actually just someone on DMT from another dimension. So it's a theory. It's a theory.
you come up with some weird shit. I think you're on DMT half the time.
Maybe, maybe. Don't tell my job.
Yeah.
Yeah, yeah.
Uh, All right, guys. I appreciate you guys. Thanks for tuning in. If you're watching this not live, don't forget to hit the comments. I appreciate you commenting, Tony Vidal. I'm wondering if that's on that. Yeah, I think that was on my side. But anyways, appreciate commenting, Tony, and then my wife for reminding me what the previous episode was. Remember, we're just two humans that don't know a lot of science, but we like to talk about that stuff. So your comments is what helps us learn. If anything, we're here to learn more than we are here to educate, but also have interesting conversations around science. And your comments help that a lot. So
Yeah.
go check out Richard at on Facebook. Say that thing again, Richard. Just Richard Fletcher on Facebook for right now.
Yep, just Richard Fletcher on Facebook. YouTube is Engineer of Reality, and I have again haven't put anything on there except for these episodes.
Yeah. At some point, I'm sure he'll put up some more stuff, but apologize that we were gone, but life gets in the way, and when this is more of a hobby than anything else, that's excuse me, that's how it goes. So appreciate you guys tuning back in and having this conversation with us. We shall see you the next time.